Hi, my name is Jonathan Charles, and welcome to Performing a Migration, Part 2. If you haven't seen Part 1 yet, I would go back and watch that one, just because to keep things in order, and I'm going to build on what we just said, so if you missed that part, it could be weird. So in many networks, SD-WAN isn't going to be deployed in a greenfield environment, which is why it's important to understand how to introduce that into an operational network. We're going to discuss various migration scenarios, which includes introducing SD-WAN into the data center, and introducing SD-WAN into the branch offices, and replacing all those legacy customer edge devices and ensuring that coexistence of traditional WAN and SD-WAN devices. Once you're done here, you should be able to describe those use cases for migrating those branch sites to a hybrid model. So this example is going to demonstrate another method of introducing SD-WAN to the branch site. One internet and one MPLS connection is assumed. The goal is to retain the CE router because they have advanced features they don't want to lose. And there's a list of some unified communications, wide area application acceleration. Just so you know, the SD-WAN solution does not support serial interfaces. So if you have point-to-point T1s, which you probably don't anymore, but if you did, you'd still need to terminate those on legacy equipment. Following here is the migration sequence for that hybrid branch office, starting with an MPLS overlay network. Initially, all right, so let's cover this left side. Assume that that SD-WAN site doesn't exist. Only a CE router is connected to the MPLS network. In the example on the slide, an additional transport network is being installed, and SD-WAN is used to manage the traffic between the transport networks. All right, so we're adding a new internet circuit, and we put an SD-WAN device in. The new internet connection is plugged into the newly installed SD-WAN router. Initial bring-up could be done through plug-and-play. The two edge routers are connected as shown. So we have two separate interfaces here. All right, this isn't one big fat pipe. This is two separate ones. Two separate interfaces, one for VPN 0 connected to our overlay network, basically dragging that down that way, and one service side for VPN 10, dragging that down that way. So the goal here is that we basically use that amoeba pseudopod to drag the interface across the connection. And we configure that SD-WAN edge is configured with those two VPN interfaces. So you will need two new interfaces on that CE router for this to work. And remember the vEdge 1000, for example, has 8 interfaces on it, so we have plenty of capacity on the vEdge devices for this task. Even the lowest model, the 100, has 4 Ethernet interfaces on it. Okay? So the two edge routers are configured with VRRP, right? So we discussed VRRP in a previous section. This is Virtual Router Redundancy Protocol. So basically the inside interface here is going to have a shared virtual IP, and basically whoever's active will respond to ARP requests for that IP address. The CE is active and the SD-WAN router is in standby mode. This means now all traffic is going to go through the CE router. So all offsite prefixes, both SD-WAN and non-SD-WAN, are received over the SD-WAN tunnel via OMP. The router is going to redistribute this information to the local routing protocol and announce the prefixes to the customer edge. So we're going to send those prefixes over VPN 0 back to this guy. Local prefixes are announced exclusively through SD-WAN. The CAE does not announce any local prefix, with the exception of the VPN 0 interface of the SD-WAN router. So all of our communication to the inside of the network is done on the SD-WAN router. There's no routing done this way at all, other than the fact that VRRP is being run, right? So even though this is my default gateway, all the advertisements back and forth are through this router. The end result here is that all outgoing traffic goes first to the CE. Remember, because the CE is priority for VRRP. Right? So even if you're a PC here, your default gateway is always going to be that guy as long as he's up and running. Okay? Then, from the CE to the SD-WAN router, Actually, I'm not going to draw that. Just follow the blue line, and you'll see where it's going. The SD-WAN router now routes traffic between the two transport networks, internet and MPLS. Non-SD-WAN traffic is sent the same way to the data center, then sent from the data center to a non-SD-WAN site. Okay? So remember, this non-SD-WAN site has no connection to the SD-WAN environment. It does to MPLS, but we're not going to connect that way. We're only going to connect this way because we're going to be advertising our routes via SD-WAN. Remember, only the SD-WAN router is announcing these service-side routes for VPN 10. Okay? The CE router is not doing any advertisements of routes outbound. Therefore, all return traffic is going to come this way, and all sent traffic is going to come this way. So all of our traffic is actually SD-WAN, even though we are connected via MPLS on the CE router. Remember, from the SD-WAN router, this looks like just another tunnel interface for VPN 0. So we're forming tunnels over both of these directions. If desired, we can also send non-SD-WAN traffic directly through this CE. If so, then the routing configuration is slightly different. The physical setup, however, is going to be exactly the same. Remember, we're still active on the CE router and standby on the V-edge. So in this case, the SD-WAN router should not know about non-SD-WAN prefixes. All right? So this non-SD-WAN, he has no idea that route exists. Those prefixes are only known to the CE because we want that traffic to route through the CE. So now the CE has all the non-SD-WAN routes. So now the downside here is the CE routes the SD-WAN prefixes to the SD-WAN router, right? So if you're an SD-WAN site out here, we're still going to route traffic that way, which routes them into the SD-WAN overlay. Underlay prefixes should never be announced into the overlay. Okay? And what I mean by underlying prefixes, I mean that /30 for the MPLS, etc. The result of this setup is that all SD-WAN traffic is always routed to the SD-WAN router, right? So our SD-WAN traffic. I know we're saying SD-WAN, non-SD-WAN. I wish we had a better phrase for non-SD-WAN traffic, but I just don't want to confuse the issue here. If you're an SD-WAN site, which means you have a V-edge device at your location, that traffic we want always going over our SD-WAN fabric. Okay? So remember, we're always going through the CE router first because we're active for VRRP. We then get routed to the V-edge because the V-edge is advertising those routes to us. Then, from the V-edge's perspective, this MPLS connection, this router is essentially just in front of the V-edge device. So you have to look at this as instead of a logical path, as a physical path, it actually looks like this. CE router, V-edge, CE router again, MPLS. And this is VPN 0 here. So from the SD-WAN's router, it just has a connection to the MPLS. Even though it is physically through the CE, and we are going through the CE twice, we're actually, it is still a linear path. Okay? This is a configuration to make Rube Goldberg proud, but it does work. The SD-WAN router has two transport networks at its disposal, the internet connection and the MPLS connection, going through the CE router. So this one and that one. Note that latter connection, the CE is viewed simply as part of the underlay, and as shown right here. The resulting MPLS traffic goes to the customer edge, which routes the traffic directly to the target MPLS site. Okay. That's the target MPLS site there. So, if non-SD-WAN traffic is going through the data center, the migration is implemented with the following steps. The starting point is a dual-core switch setup, okay, both of which are connected to the CE. Here's our CE. CE stands for customer edge, so if you see that phrase and you're wondering what we're referring to. So all MPLS is delivered as both a provider edge and a customer edge piece of equipment. The provider edge is their demarc of their limit of responsibility. The customer edge is your limit of responsibility. And then the link is between them. Okay? The CE is usually your device, and the PE is definitely always the provider's device. All right. Anyway, but generally the CE is going to have the MPLS connection. So You add and wire up the new SD-WAN devices shown in the slide. We're going to have a link between the two, and we're going to full mesh. We're going to have a link between the two core switches. The new internet connection is directly connected to the SD-WAN router. In this case, a single connection between SD-WAN router and CE is required instead of two, and we'll show you why in a second. During the cabling and physical setup, traffic is not disturbed and continues to be routed through the CE. We have made some physical connections, but we're not modifying any of the routing or anything that's going on the CE device. When configured, the SD-WAN router establishes a tunnel across the internet and receives SD-WAN and non-SD-WAN prefixes through the overlay connection. So be here, and then adds those prefixes to the routing of the two core switches. The SD-WAN router redistributed those prefixes from OMP into the local routing protocol, OSPF or BGP. I know this question is going to get asked, so I'm going to say it. We don't support EIGRP at this time. Now, the core switches have routes for SD-WAN and non-SD-WAN prefixes through the SD-WAN router. From the MPLS side, the CE receives all non-SD-WAN prefixes and forwards those prefix announcements to the core switches. Okay? So all MPS routes are sent this way and redistributed as they were before. Now the switches are going to see the following. For SD-WAN routes, a path through the SD-WAN router and the CE router. For non-SD-WAN routes, a single path through the customer edge. The SD-WAN router should be preferred even for the non-SD-WAN prefixes. The SD-WAN router routes traffic to the non-SD-WAN through the data center in this example. The resulting traffic is always going to go through the SD-WAN router as a primary path. The SD-WAN router follows the SD-WAN policy to send traffic through the transport networks to the data center, and non-SD-WAN traffic is sent from the data center to the MPLS site. So, and the whole purpose of this was to retain the customer edge device. So if we want to send non-SD-WAN traffic directly through the CE to the MPLS network, only SD-WAN prefixes are announced through the SD-WAN tunnels. They get redistributed to the local routing protocol and are sent to the core switches. Okay? So SD-WAN, SD-WAN, SD-WAN. No non-SD-WAN prefixes are coming from here. This would have to be controlled at that main site, though. Non-SD-WAN prefixes are received only over this customer edge router. And from the CE, the non-SD-WAN prefixes are announced to the core switches. So non. Remember, these are non-SD-WAN prefixes. In this example, the core switches have two routes. Traffic to SD-WAN prefixes sent to SD-WAN router. Traffic to non-SD-WAN prefixes sent to the CE first, and from the CE into the MPLS network. Note, the underlying prefixes should never be announced into the SD-WAN overlay. Okay? That's, when I say underlay prefixes, what I mean by that are the /30s, any of the public IPs here, etc. So these link interfaces should never be advertised into SD-WAN. Equally, SD-WAN prefixes should not be announced on the MPLS side. Okay? So if we learn all these SD-WAN prefixes, we shouldn't advertise them back out because we could cause a routing loop. This way we can maintain strict separation from both paths. Note here there's no failover between the routers and the connections in this example. A loss of either side leads to a loss of traffic from and to that side. So if we lose the MPLS, we lose access to the MPLS routes. The result here is that all SD-WAN traffic is always sent to the SD-WAN router, right? The router uses both transport networks, following the policy defined in vManage. Note that the customer edge, as seen from the SD-WAN router, is just the next hop in the underlay network. It doesn't look like anything else. Remember I drew those before, CE, SD-WAN, CE, right? Because at the end of the day, they're connected. Even though we're going through the CE router twice, we actually are connecting to it directly. However, just so you know, traffic to non-SD-WAN sites is exclusively routed to the customer edge and from there into the MPLS network. So in summary, you can convert and migrate branch offices to a hybrid model in order to maintain availability of legacy services. Like let's say you have a UCSE module on a router providing services to that local site. Obviously, the SD-WAN solution is predominantly a WAN solution. It isn't intended to replace the entire Cisco product line and all of the features that we've seen in the Cisco routing environment. Okay, that's the end of this topic and the end of this section. So just a reminder, SD-WAN solution interoperates with non-SD-WAN components depending on the requirements, such as when you must support routers with advanced services that are not yet SD-WAN compatible. For example, probably the better example is a Cisco router that's currently doing PSTN access. Obviously, we're not going to support that in an SD-WAN environment. You're going to need to retain that router. Migration from those traditional WAN to either pure SD-WAN or hybrid SD-WAN is possible. First, we upgrade the data center. Then we upgrade the individual branches to connect to that data center. And we can do that in either a pure or hybrid SD-WAN. Pure being just an SD-WAN router at the site providing WAN services, or hybrid where we have the SD-WAN router alongside a regular Cisco router providing other services as well. Thank you for watching, and that's the end of this section.